Hello everyone, welcome back to RESHMI'S corner. Today we're going to deal about the topic trigonometry for CBSE 10th grade, and trigonometry alone carries 12 marks. So let's go on to some important questions which are frequently asked for your boards, which you must surely go through before you get ready for your exams. So let's move on to the first question, which is evaluate tan 65 degree by cot 25 degree, and this question carries 1 mark. Now how can you do this? First you need to simplify. So how do you do that? Expressing 65 in terms of 25. So how can you express 65 in terms of 25? I can write it as tan of 90 minus 25 degree by cot 25 degree. Now what is tan of 90 minus theta? We know tan of 90 minus theta is equal to cot theta. So here you can write it as cot 25 degree by cot 25 degree, which is equal to 1. This is the easiest type of questions which are asked as 1 mark question. Now let's move on to the second question, which is a 3 mark question, and the question is evaluate cos 58 by sin 32 plus sin 22 by cos 68 minus cos 38 into cosec 52 by root 3 into tan 18, tan 35, tan 60, tan 72, tan 55. So how do you do this? First of all, we try to simplify for our given question. So how do I do that? Cos 58, I can write it as cos 90 minus 32 degree by sin 32. Next, sin 22, I write it as such, sin 22 degree by cos 68. How do I write? Cos of 90 minus 22 degree minus cos 38, I write it as such, cos 38 cosec 52. How can I write it? Cosec 52, I can write it as cosec 90 minus 38 by root 3, I write it as such, root 3 into tan 18 into tan 35 into tan 60. What is the value of tan 60? Root 3. So I write root 3 into tan 72. How can I write it as? Tan 90 minus 18 into tan 55. How can I write? I can write it as tan 90 minus 35. So now we have cut short our angles to less than 90 degrees. That is equal to, what is cos of 90 minus theta? Cos of 90 minus theta is sin theta. So I write it as sin 32 degree by sin 32 degree plus sin 22, I write it as such, cos of 90 minus 22, I can write it as sin of 22 minus cos 38, again I write it as such, cos 38 cosec 90 minus theta, I can write it as sec theta. So that here I can write it as sec 38 degree by root 3 into root 3. How can I write it as? I can write it as 3 into tan 18. I write it as such, tan 18, tan 35 degree, 35 into, now what is tan of 90 minus theta is? Cot theta. So this I can write it as cot 18 degree. Now tan of 90 minus 35, I can write it as cot 35 degree. Now let's see what all we can cancel. Sin 32 and sin 32 I can cancel. Sin 22 gets cancelled again. Now cos 38 and sec 38 also get cancelled. Why? Because sec theta is equal to 1 by cos theta. So I can cancel this. Now tan 18 and cot 18 I can cancel. Why? Because cot 18 is 1 by tan 18. Cancel. Again tan 35 and cot 35 again I can cancel. Why? Because cot 35 is equal to 1 by tan 35. So what is remaining? 1 plus 1 minus 1 by 3, which implies 2 minus 1 by 3, which is equal to 6 minus 1 by 3, and our answer is 5 by 3. So that was a 3-mark question. Now let's move on to the third question. If sine a plus 2b is equal to root 3 by 2 and cos of a plus 4b is equal to 0 and a is greater than b and a plus 4b is given to be less than or equal to 90 degree, then find a and b. So you need to find out a and b. So now let's take down and write the two conditions which is given, which is sine a plus 2b is equal to root 3 by 2, and the second condition is cos a plus 4b is equal to 0. Now how can I write this root 3 by 2 in terms of sine? So that I can write it as sine a plus 2b is equal to sine 60 is root 3 by 2. So sine 60. So comparing the angles, what do I get? This implies a plus 2b is equal to 60 degree, which implies a is equal to 60 degree minus 2b. This I write it as equation number 1. Now I go on to the second condition, which is cos a plus 4b is equal to 0. Now how can I write 0 in terms of cos? I can write it as cos a plus 4b is equal to cos 90 degree. Now when I compare the angles, what do I get? This implies a plus 4b is equal to 90 degree, which implies a is equal to 90 minus 4b. Now from 1, what do I get? A is equal to 60 minus 2b. So I substitute that here. A as 60 degree minus 2b is equal to 90 degree minus 4b, which implies I'm bringing b's on one side. So I get 4b minus 2b is equal to 90 degree minus 60 degree, which implies 2b is equal to 30 degree, which implies b is equal to 15 degree. And this I name as my second equation. Now let's substitute this 2 in 1. So putting 2 in 1, what do I get? A is equal to 60 degree minus 2 into b. I have got it as 15 degree. So I write it as 15, which is equal to 60 degree minus 30 degree, which is 30 degree. So I got the answer A as 30 degree and B as 15 degree, which was our question to find the angles A and B. So now let's move on to the fourth question, and this was a 3-mark question. Fourth question, prove that sine A minus 2 sine cube A by 2 cos cube A minus cos A is equal to tan A. And this is a 4-mark question, and this is a repeatedly asked question. So now let's see how to prove it. First we take our LHS. Now what is our LHS? It is sine A minus 2 sine cube A by 2 cos cube A minus cos A. Now from the numerator, what can you take common? I can take sine common. So I am taking sine A into 1 minus 2 sine square A by, from the denominator, what can I take common? I can take cos A common. So I write cos A into 2 cos square A, 2 cos square A minus 1. Now here, what is sin A by cos A? It can be written as tan A. So that implies tan A into 1 minus 2 sine square A, I am writing it as such, by what is remaining? 2 cos square A minus 1. Now this cos square again I can represent in terms of sin square A. How can I write cos square A in terms of sin square A? Cos square A is equal to 1 minus sin square A. So I am writing it as 2 into 1 minus sin square A minus 1. Now I am opening the brackets here. So which is equal to tan A into 1 minus 2 sin square A by, when I open the bracket, what do I get? 2 minus 2 sin square A minus 1. Now what is this 2 minus 1? 1. So I can write it as tan A into 1 minus 2 sin square A by 2 minus 1, 1. So 1 minus 2 sin square A. 2 sin square A. So now I can cancel this 1 minus 2 sin square A and 1 minus 2 sin square A. I get the answer as tan A, which is our RHS. Hence, proved. So, this was a 4-mark question. Now, let's move on to 5th question. So, the 5th question is, prove that 1 plus cot A plus tan A into sin A minus cos A is equal to sec cube A minus cosec cube A by sec square A into cosec square A. So, now, how do you prove that? Let us take the LHS first. What is the LHS? 1 plus cot A plus tan A into sin A minus cos A. So, how can I simplify this? I can express cot and tan in terms of sin and cos. So, how do I do that? 1 plus cot is cos A by sin A plus sin A by cos A into sin A minus cos A. Now here I am taking the LCM. So what do I get? Sin A cos A plus cos square A plus sin square A by sin A cos A into sin A minus cos A. Now, doesn't this look similar to an identity? Which is the identity here? It is A cube minus B cube is equal to A minus B into A square plus AB plus B square. This is the identity which is used here. So, this I can write it as sin cube A minus cos cube A by sin A cos A. So next what I am going to do is I am going to divide the numerator and the denominator by sin cube A into cos cube A. So we are going to divide the numerator and denominator by sin cube A into cos cube A. So what do we get? I get sin cube A by sin cube A cos cube A minus cos cube A by sin cube A cos cube A by sin A cos A by sin cube A cos cube A. So what do I get? I get sin cube and sin cube I can cancel. So I am cancelling sin cube A. Here cos cube A I can cancel. Here sin A and cube gets cancelled to square, cos A and cube get cancelled to square. What do I get? I get 1 by cos cube A minus 1 by sin cube A by, here what is remaining? 1 by sin square A into cos square A. 1 by sin square A into cos square A. Now let's put this in terms of sec and cosec, as our RHS is in terms of sec and cosec. So what do you get? This implies sec cube A minus cosec cube A by cosec square A into sec square A, and this is our RHS. This was again our 4-mark question. Now let's move on to 6th question. If x is equal to r sin A cos C, y is equal to r sin A sin C, and z is equal to r cos A, then you need to prove that x square plus y square plus z square is equal to r square. Now this is a 4-mark question. So let's start. How do we do this? We can square and add. You need x square plus y square plus z square. So let us square all these and add. So I get x square plus y square plus z square is equal to r square sin square A cos square C plus, now y square will be r square sin square A sin square C plus z square will be r square cos square A. Now from these first two, what can I take common? I can take r square sin square A. So what is inside the bracket? Cos square C plus sin square C plus the remaining is r square cos square A. Now what is cos square C plus sin square C? It's 1. So you get r square sin square A plus r square cos square A. Now from here what can you take common? You can take r square common. So you get sin square A plus cos square A. Now what is sin square A plus cos square? Which is 1. So you get the answer r square, which is the RHS. So now let's move on to the next question, which is the 7th question. Let's prove that cos square theta by 1 minus tan theta plus sin cube theta by sin theta minus cos theta is equal to 1 plus sin theta cos theta. So first let us take the LHS. LHS is cos square theta by 1 minus tan theta plus sin cube theta by sin theta minus cos theta. So now let us express this tan as sin and cos, as what we have to prove needs only sin and cos. So this can be written as cos square theta by 1 minus sin theta by cos theta plus sin cube theta by sin theta minus cos theta. So now we can find the LCM. So what do we get? We get cos square theta by cos theta minus sin theta by cos theta plus sin cube theta by sin theta minus cos theta. So we get cos cube theta by cos theta minus sin theta plus sin cube theta by sin theta minus cos theta. I need to make these denominators same. So what can I do? I can take this minus here. So it becomes cos cube theta by cos theta minus sine theta minus sine cube theta by cos theta minus sine theta. So now I can take this denominator common. So I get 1 by cos theta minus sine theta into cos cube theta minus sine cube theta. Now what is this form? A cube minus b cube. Now what is this a cube minus b cube expansion? A cube minus b cube is equal to a minus b into a square plus b square plus ab. So let us expand. You get 1 by cos theta minus sine theta into cos theta minus sine theta into cos square theta plus sine square theta plus cos theta into sine theta. So now what is this cos square theta plus sine square theta? Becomes 1. And you can cancel this cos theta minus sine theta into cos theta minus sine theta. So I cancel this. So what will you get? 1 plus cos theta sine theta, which was our RHS of what we have to prove. Hence proved. So that was a few questions from the topic trigonometry. So see you some other day with some other topic. Bye.